In the next one, we have a student throwing a ball horizontally off the roof of the Chase building in downtown Dallas, 125 meters above the ground. Ball hits the ground 100 meters away. How fast does the student throw the ball? So the first thing we want to do, always sketch it out. Remember, it doesn't have to be a sketch that is going to win many awards, but it should at least show what is happening. So we're throwing the ball horizontally off of a building that is 125 meters off of the ground. So the ball is going to travel like this. Starts off horizontally and then accelerates downwards. Meanwhile, it lands 100 meters away. Obviously, this is not to scale, as my 100 meters is a lot shorter than my 125. But that doesn't matter. And then we also have acceleration going down, where g equals 10 meters per second. Downwards. All right, so the solution. We realize that this is an object traveling through the air, so that's a projectile motion, so it's moving through the x direction and the y direction at the same exact time. So, with that in mind, we need to keep our y and x information separate from each other. So what information do we have in the y? If we were to list out all of our givens in the y, I would say, first of all, the easy one, right? G equals 10. Tells us right there in the problem. We have the delta y of 125 meters. And is that it? Oh, no! It's a horizontally launched projectile. So that means our initial velocity in the y is going to equal 0. Because when we break the initial velocity vector into its components, there is no y component. A horizontally launched object goes at angle 0, and when you multiply sine 0 to anything, you're going to get 0. So next we have in the x direction. Speaking of velocity, if we have 0 y velocity with a horizontally launched projectile, that must mean our initial velocity, all of the initial velocity, belongs in the x. Doesn't say anything about air resistance. There's no reason to believe there's air resistance. So that means our final velocity is also going to equal our initial velocity in the x. It's just not changing. There's no acceleration in the x direction. We have the range, or displacement, along the x-axis to be 100 meters. And we don't have anything else. All right, so where are we going? That's the first question I would ask yourself. Where are we going with this? If you know where you're going, then you can figure out a way to get there. I would say, more often than not, if we're looking in the x direction, we have velocity and we have displacement. Remember this? Velocity equals displacement over time. That's where we're going. That's a little sneak peek for you. Let me go through the whole thing. So let's go to our kinematic equations. We have our displacement, delta x, equals v naught x times t plus 1/2 at squared. And there is no acceleration in the x direction. We can even make a note of that if it helps us. So all of that goes away, as long as there's no air resistance. So we're left with that equation. And we're trying to solve for our initial velocity in the x, because if we find our initial velocity in the x, we have found our initial velocity, and the initial velocity is exactly what the question's asking us for. So when we solve this equation, we get v naught x equals delta x over t. Remember what I just showed you? That's where we were going. All right, the problem here is we don't have t. I would say 80 to 90% of the time, if you are looking for a time, you're going to need to look in the other dimension. So in this instance, the other dimension is y. So how can we get t from here? Well, we have displacement and we have the initial velocity. So let's check that out. Delta y equals initial velocity in y times t plus, minus 1/2 gt squared. The initial velocity in the y is 0, so all of this mess goes away. And what we're left with is the y displacement equals negative 1/2 gt squared. We can rearrange this equation and solve for t, and we're going to get t equals the square root of 2y over g. Negative 2y over g. The y displacement, we're starting off from 125 and we're ending at 0. So final minus initial, 0 minus 125, is going to give us negative 125. So there's the negative 2 from this fraction, and then there's a negative from this y. So negative times a negative will give us a positive. So don't you worry your little head about a negative under the radical. Okay, we've done a lot so far. Pause it, go back and catch up. Ask questions if I went too quickly. We haven't solved it yet, but we've done a lot. That's good. Another good thing is the likelihood of you having to go through every single step in this on your AP exam is pretty low. You may need to do a lot of this for a free response question, but a multiple choice question, absolutely not. All right, so t equals the square root of that. So I can plug all of this into this equation right there. And that's what I'm going to do. And it's going to be messy and ugly, and that's okay. I just want you to see 2y over g. So what we have done right now is we haven't plugged in any numbers. We've only been working with equations. So this process that we've done is we have derived an equation. We've derived an equation. I showed you all of the steps to get to this equation. And now using this equation, do I have delta x a number? Yeah, I do. Do I have y and g and I can solve this denominator? Absolutely. So we can get a numerical answer, and that's just great. But more importantly, I need you to know how to get to this equation. All right, so let's continue on quickly and pop in these numbers. So we have delta x is 100. All of this junk, 2 times this 150 divided by 10. 250 divided by 10 is 25. Square root of 25 is going to give me 5. You can plug in the numbers in your calculator to double check me if you like. But I am saying our initial velocity is 20 meters per second. And I'm going to go graph it. So we said the total time was 5 seconds, so we're going to use this entire x-axis here. Our horizontal distance, we started at 0, and where did we end up? We ended up 100 meters away. So that's what our graph is going to look like there. Horizontal velocity, remember, was not changing. So we figured it was 20 meters per second, so it's 20 meters per second. And if our horizontal velocity is not changing, that must mean we have 0 horizontal acceleration. For the vertical velocity, we started at 0, we ended with negative 30 with a straight line because we have a constant negative acceleration in the downward direction of negative 10. So important points. Only for ground-to-ground launches, horizontal initial velocity is equal to the initial velocity. The vertical initial velocity is equal to 0, and those are your 2 projectile motion simplifications.